The arrival of an unexpected visitor from another star system, hurtling unannounced through the inner regions of our solar system, naturally captures enormous attention and triggers waves of curiosity, speculation, and scientific excitement. The object now known as 3I/Atlas is only the third confirmed interstellar object ever detected, joining the likes of 1I/Oumuamua and 2I/Borisov. Because such visitors are so rare and mysterious, it is no surprise that 3I/Atlas quickly became the subject of dramatic claims, including suggestions that it may be an alien spacecraft or some type of engineered probe. However, as astronomers gather more data, a much clearer and far more grounded picture is emerging. A growing body of observations overwhelmingly confirms that 3I/Atlas is a natural comet originating from outside our solar system, and not a technological artifact crafted by an extraterrestrial civilization. Observations from a variety of telescopes, including high-quality data obtained by Gemini South as part of the NOIR Lab Educational Observing Program, have revealed unmistakable features: a diffuse, glowing coma and an extended tail sweeping behind the object. These are the classic signatures of a comet undergoing sublimation as it approaches the sun. They are not camera artifacts, not tricks of the atmosphere, and not illusions produced by faulty instruments. They are genuine physical expressions of volatile materials, such as various gases and frozen compounds, being heated by the sun's radiation and transforming directly from solid to gas. As these volatiles vaporize, they lift dust and ice particles from the comet's surface, creating the hazy halo of the coma and the long, sunlit tail. These features alone strongly distinguish 3I/Atlas from asteroids, which lack the necessary icy composition to form such structures when warmed. Even a casual visual inspection reveals this distinction. Asteroids, being largely rocky or metallic, remain inert even when they pass close to the sun. Their surfaces do not ignite into glowing hazes or erupt with vaporizing ices. Comets, on the other hand, are primitive bodies rich in frozen materials such as water ice, carbon dioxide, methane, ammonia, and other volatile compounds preserved since the formation of their home systems. As they draw nearer to their star, these ices boil off into space, dragging dust along and leaving behind the sweeping, iconic cometary tail. The behavior of 3I/Atlas fits this pattern perfectly, demonstrating natural processes we have observed countless times in comets born within our own solar system. Beyond visual appearance, 3I/Atlas also behaves dynamically like an ordinary comet, further weakening any claims of alien origin. Artificial probes, especially those constructed by an advanced intelligence, would likely display movements inconsistent with pure gravitational physics. They might accelerate, decelerate, change course intentionally, or perform maneuvers, just as human spacecraft do. But 3I/Atlas has shown none of these signs. Its motion through space follows the simple, predictable path determined by its incoming trajectory and the sun's gravitational influence. There are no bursts of thrust, no peculiar deviations, and no evidence of guidance systems. The object is coasting freely through space, just as natural interstellar debris would. If one imagines an alien civilization sending a probe across the galaxy, it is reasonable to expect that such a device would be constructed to operate efficiently and withstand interstellar travel. Human-made probes, for example, are built with rigid surfaces, clear shapes, and well-defined structures. They do not disguise themselves behind glowing hazes of vaporized ices. Any advanced extraterrestrial probe would likely be visible as a solid object with identifiable geometry. Yet 3I/Atlas is literally obscured by a cloud of dust and volatile gases. Its form is hidden beneath the activity of sublimation. This is exactly what we see in natural comets, but not at all what we would expect from technology. Moreover, an alien probe might be programmed to pass closer to planets for observation or data collection. Instead, 3I/Atlas remains on a distant, indifferent trajectory, sweeping by without any apparent interest in the worlds it encounters. One of the most definitive scientific tools used to study objects in space is spectroscopy, a technique that breaks light into its component wavelengths to reveal the chemical signatures of materials present in an object. Spectroscopy provides astronomers with the ability to identify the composition of stars, planets, nebulae, and even the dust surrounding comets. Recent spectroscopic observations from the Very Large Telescope (VLT) have provided crucial evidence about the composition of 3I/Atlas. These observations detected familiar molecules commonly found in comets originating within our solar system. The presence of these molecules, many of which correspond to well-known cometary volatiles, strongly supports the conclusion that 3I/Atlas is composed of natural materials and is not artificial. While the chemical composition of 3I/Atlas is not identical to that of solar system comets, the differences are subtle and scientifically fascinating rather than mysterious. Variations in chemical makeup are expected for an object formed in a completely different stellar environment. Each star system forms under unique conditions, with its own blend of elements, temperatures, radiation levels, and cosmic histories. Just as comets in our solar system can differ in their compositions depending on where they originated, an interstellar comet would naturally carry the chemical fingerprint of its birthplace. These differences, therefore, offer a rare scientific opportunity to learn about the diversity of planetary systems beyond our own. Far from indicating alien engineering, the chemical variations in 3I/Atlas are precisely what scientists would predict from a natural object shaped by the conditions of another star. The study of interstellar objects is still in its infancy, with only 3 confirmed visitors so far. Each new detection provides astronomers with invaluable data about how planetary systems form, evolve, and interact with the vast environment of the galaxy. 3I/Atlas adds an important chapter to this emerging field. Its behavior, appearance, and chemistry all align with our growing understanding of interstellar comets. The fact that it behaves so similarly to solar system comets reinforces a crucial scientific principle. The processes that govern the formation of small icy bodies appear to be universal, not confined to our local neighborhood. Comets may be common byproducts of star and planet formation throughout the Milky Way, wandering silently between systems until gravity occasionally sends them past another star. Claims of alien involvement, while exciting, often arise because interstellar objects evoke wonder and mystery. Humanity has always been curious about the possibility of extraterrestrial life, and unusual cosmic visitors act as perfect canvases for speculation. Yet scientific evidence remains the most reliable guide, and in the case of 3I/Atlas, the evidence consistently points toward a natural origin. It shows every characteristic of a typical comet: sublimation-driven activity, gravitationally governed motion, a dusty coma, a vaporizing tail, and a chemical composition shaped by natural processes rather than artificial construction. No observation suggests the presence of technology, structure, or intent. Instead, 3I/Atlas stands as a remarkable natural traveler from a distant star system, carrying with it a sample of the material formed around another sun long ago. As it sweeps through our solar system, scientists have a unique chance to study this material, compare it with our own, and expand our understanding of how star systems differ across the galaxy. Each sublimating molecule and dust-filled plume offers clues about the environment in which this comet first took shape. By studying objects like 3I/Atlas, astronomers can explore questions about the diversity of planetary systems, the distribution of organic materials, and the processes that shape worlds beyond our reach. Far from being alien technology, 3I/Atlas is a reminder of the dynamic, interconnected nature of the universe. The space between stars is not empty, but filled with wandering fragments, icy messengers, and ancient remnants of long-dispersed planetary systems. When one of these objects crosses into our solar system, it allows us to glimpse the cosmic processes that unfold far beyond our sun's light. In this sense, 3I/Atlas is extraordinary not because it is artificial, but because it is profoundly natural, a pristine example of interstellar material shaped by forces that also shaped planets, moons, and comets everywhere. As it continues on its journey, drifting deeper into the darkness beyond the sun's influence, 3i/Atlas leaves behind valuable data, scientific insights, and a deeper appreciation for the shared processes that bind star systems across the Milky Way. Rather than signaling alien contact, it enriches our understanding of the universe and highlights the grandeur of natural cosmic evolution. The truth, grounded in rigorous scientific observation, is more captivating than any speculation about extraterrestrial machinery. 3i/Atlas is a natural comet, a frozen traveler from a distant origin, and a testament to the universal forces that carved the architecture of the cosmos.